Spatial hearing, I will talk about inter-time, inter-oral time difference, inter-level time, inter-oral level difference, head-related transfer functions, horizontal versus median plane, local distance, maybe BMLD, binary masking level difference. Okay, we are mostly, I will talk, this horizontal plane, and you have the median plane. The horizontal plane, here you have theta, the azimuth, and you also have the elevation. In the horizontal plane, the azimuth angle is changing, but not elevation. In the median plane, you can say of the half circle here, the elevation is changing, and the azimuth is 0, and on the other side you have backwards here. So and this elevation, yes, and ITD is because of the difference in the pathway from a sound to the 2 ears. So now we have just to a simple, we have a sound source from far away, and let's say we have an angle here by phi. Yes, then it turns out that this distance is r times sinus phi. You can do something by the angles, and this circle distance is r times phi. So delta t is delta s divided by c. So it's very simple here. You have, we assume a circle, a head formed circle formed head, especially after Christmas. We are all round. Okay, yes, and you can say it works all for best. It works for best for smaller frequencies, because if the wavelengths of the sound is less than 2 times bigger than less than 2 times the distance between the ears, there will be some phase confusion, as I understand it. So, but big for great frequencies, envelope modulation and frequencies will take over. For smaller, it's a fine structure. Yes, okay, and yes, yep. Okay, and you can say, of course, what is the dependence of the angle? You have P here, we are working in the horizontal plane. You have set 90 degrees. So in the experiment could show that the maximum time between delta time between the 2 ears is 690 microseconds. Yeah. So as of course, if it's vertical to one of the ears, the JMD varies with frequencies list minimum at 700 to 1000 hertz. Yeah, it's okay, and because of this temporal fine structure versus envelope structure is because the transformation from mechanical vibration to electrical potential is limited to high frequencies, at high frequencies. Then we have the ILD. It's because of the shadowing of the sound, because of the hit, and we know that small frequencies gives big diffraction, high frequencies low diffraction. So yeah, and you can say that it's the delta ILD is biggest for high frequencies. Yes, and you can show here on the curve 500 Hertz frequencies, and here we have delta dB levels. Yes, and for 5000 Hertz it could be like this up to, I think, yeah, no, it's the frequency is here, and this is degrees, 90 degrees. And for very small frequencies, 200 Hertz, there's a lot of diffraction. Then there is almost no gap, difference between the 2 years. Yeah, and the minimum J and D, just noticeable difference, 1 to 2 dBs. Yeah, at all frequencies. Yes. Okay. Then you have to. Sometimes you don't know where is the sound coming from front or back or low or behind or above. If you have loudspeakers, you can't say if you're on the horizontal plane, if is it from front or back or from lower or behind up. But if you turn your head, you make some head-related transfer function can help you to localize. It's a question about localize the sound, where it's coming from where in the space. Yeah. Okay. And you can have this, of course, this cone. Cone of confusion. You have a cone, and that all locations on the surface of a cone represents the same, produces the same ILD, ITD cues. Okay, good. Yes, okay. But the median plane elevation can help you to find out. You can hear if the is up or down low frequency sound. Yes, and you also have the distance. You know the pressure is from the omni as a ferric. You know that the pressure is inverse proportional to the distance, and the intensity inverse proportional to the squared. So for omnispheric, this can help you to localize in the distance. In the reverberance attenuate high frequencies. Yeah, reverberance energy. If you're close, more clear. If you are further away, less direct sound. You can also hear that. Whereas at high frequencies, you have attenuation. So more than 15 meters. So they are gone. The high frequencies lower you can hear. For smaller frequencies, less than 1/2 meter is high frequency is spherical, and the big change in the ILD, interlevel difference, because of the nearness. And you have biases, overestimate low distances and underestimate high frequencies, high distances. Yeah. So yeah. Thank you.